a vicious cycle. We will still be continuously exposed, but what is important for us is to address the source of exposure, which will be the plastics. So it's a bigger challenge for those who are in the regulators, in the industrial company, to be able to revisit and look back of what type, if we still continue on using plastics, what type of plastics that we're going to use that will make our next generations or even the current generation safe as far as our health is concerned. So maraming salamat po.
Thank you very much, Professor Panganiban, on your talk on the health impacts of plastic pollution. In the interest of time, we will have just a few questions. I have 5 here. I will give just one question. These 2 are on production. Problems on plastics are persistent pollutants, and they begin with production. One is, will it be feasible, this is from Dr. Franco Teves of MSU IIT, will it be feasible to have a gradual reduction in the production of certain plastic products, especially single-use plastic bags, and how economic losses that may result can be remedied? And the second question related to it is from Ms. Lenny Yap Dahet from the University of the Philippines, Tacloban. Mas mabigat ito. It's total ban, no? Should there be a nationwide ban of plastics? Will this make an impact or solve the problem? Is this plausible? If yes, how do we start or push for a nationwide plastic ban?
Okay, well, these are related questions. The first question is, will it be feasible to have a gradual reduction in the production of certain plastic products, especially single-use plastic bags? And the second question is, should there be a nationwide ban of plastics? Well, they're sort of related. Certainly, the objective is to have a gradual reduction in the production of certain plastic products. And the focus is really single-use plastic. Since the UN environmental group had already said that by 2030, they want to significantly reduce single-use plastic, then we're really committed to reduce single-use plastic. So the strategy is which type of single-use plastic do we phase out, and what alternatives would we have? What other measures? A nationwide ban is always difficult because if there's no alternative, then even the general population will not comply with it. So certainly the direction is towards the reduction of single-use plastic, if minimized to the bare minimum. But the alternatives had to be in place, as well as the education of the population should be there, because if the population think of it as a nuisance, then it's going to be very difficult to implement, especially because, you go to a house, even of rich or poor people, there are plastics everywhere, and you're going to tell them, no more plastics. I think it's very difficult to do that. So we have to do it in a well thought out manner. And I think from the presentation of Dr. Rola, these things you cannot just do top down and ban. There's to be public acceptance of the plan.
I think there have been suggestions and I think actions on how to go about this problem, how to at least partially solve the problem. Single-use, many manufacturers now are going to have to make recyclable plastic bottles, so that just like glass bottles, you can return it and then use it many times. Now, I think the problem with single-use plastic is too thin. So there's now a move to ban very thin plastics. so they can be reusable. The problem why we throw it away is you cannot practically use it second time. But if you make it thick enough, just like other packaging materials, if they are durable and usable many times, then it's not single use anymore. So I think if there's a policy that the manufacturers should not make very thin plastics, then they can be reusable and durable.
Thank you very much. The second set of questions from Joy Hamago from CMU, Central Mindanao University. The plastic problem in the country is complicated. We need to have changes in mindset, behavior, and commitment. Will there be a national program to be involved like the GAD concern that became institutionalized in every government unit? The second one from Dave Cruz of DND for Dr. Agnes Rola. Prevention is better than cure. With this principle, can this principle be adapted to solve waste reaching water resources? Strictly enforce no littering to address root cause. Educate and develop a culture of cleanliness. Social engineering.
Okay, thank you for the questions. Yeah, I agree with you that the plastic problem is very complicated. It will take political will, number one. It will take our changes in behavior. Okay, how do we, I mean, like the sachet culture, for instance, is with us. I mean, I think it's unique in the Philippines. So how do we deal with getting out of the sachet culture? There needs to be a lot of incentives and disincentives in how we act with respect to our use of plastics. There are success stories nationwide, but these are not really full successes because we cannot totally ban plastics in our lives at this time. But it can, I'm not sure if it can be done, but in Los Baños, for instance, the local government had already banned plastics from the merchandise. Okay. So yeah. Will there be a national program? We just need to have, first of all, a very good implementation of our solid waste management, to my mind. If we have that, then we can solve the plastics problem, partially, not fully maybe. On the second question, yeah, prevention is better than cure. Strictly enforces no littering. Yeah. So I think this second comment, this is a comment and not a question. And again, going back to social engineering, going back again to behavioral changes. So how do we do that? And social scientists are very much challenged in terms of research. We need to do more research into psychology, into why people do the way they do things, why people behave the way they do. I think those are some of the things that we need to do.
Thank you.
Social science challenge.
Dr. Panganiban.
The third component of the risk analysis is the risk communication. And I think that's where a big challenge is for us. How do we buy in people? How do we encourage people to buy in into the idea of reducing and eventually saying no to plastics? Maybe as scientists, we think, how can we establish the cause-effect relationships and all that? But I would still think that the third part of the risk analysis framework of risk communication is a job for each and every one of us to be able to allow each and every Filipino to be able to buy in into that particular idea of seeing the risks of the use of plastic and how we can, at the end of the day, reduce and say no to the use of plastic.
Thank you, Dr. Panganiban. Let me ask Dr. Panganiban one question. You're familiar with the eco bag that you can buy from grocery stores, supermarkets. These eco bags are very light. After 2 to 3 years, they are pulverized. So what will be the impact of this kind of eco bag to our health?
Okay, number one, there is a physical effect because when you pulverize, and therefore the dust that will be produced from this material can also by itself be harmful to our lungs.
Okay.
So the physical component is there. Of course, number two will be the chemical component. Though, as what I have presented in the lecture about the fallout, okay, there have been initial studies as those that have already been brought into the terrestrial area from the wind, from the sea, and they're seeing that it can be another source of exposure to us.
Thank you very much. This is an example of a reusable bag, but it's not a good plastic bag. So I think we should include that in our recommendations, the single-use plastic bag, minimize, reduce, and probably not do it anymore, and also this kind of eco bags. And let's do our own. When we go back to our own institutions, we know there are cafeterias, and people buy takeaway meals in plastic bags. If we can ask our directors to talk with the owner of the cafeteria and also send a memo that such single-use bags not be used anymore, that they should bring reusable plastics or sell them at a cost, of course. So with that, let us thank our speakers and panelists and our rapporteur for this very interesting session. And may we now call on NAS President Academician Rodora B. Asanza and also NAS Vice President Academician Fabian Dairig for the presentation of certificates and tokens of appreciation.
Sa iyong mga kapaligiran, kay dumi na ng hangin, pati na ang mga ilog natin. Hindi na masamang pag-ulat at malayo.
Ladies and gentlemen. Ladies and gentlemen, how about another round of applause to our moderator and our speakers? This currently ends the plenary session on plastic waste. We would also like to thank our moderator, Academician Mendoza. Plenary session 3 on sustainable marine and food security will be moderated by Academician Mujikiwis D. Santos, member of the NAST Agricultural Sciences Division. Thank you. Welcome to plenary session 3 as we welcome on stage Dr. Wilfredo L. Campos, Academician Marco Nemesio E. Montano, Dr. Ephraim B. Metilio, Academician Cesar L. Villanoy, and Dr. Aleta Concepcion Iniguez. Please give them a round of applause. And to moderate the last part of today's program, plenary session 3, another round of applause to NAST Philippines Academician Mujikiwis D. Santos.
Good afternoon. Isa pa. Good afternoon. Hello? Hi! Ayan, pwedeng-pwede pa. Well, nagme-merienda yung iba, but may I ask everyone to stand up? Mag-stretching lang tayo ng konti. Kasi parang ang dami kong nakikitang nagyoyon kanina pa. Okay, mabilis lang po. So, taas lang yung ating kamay. And then, reach for the sky. Ayan. And then, bend. To the left, then bend to the right, and then shake your hands, and we're done. Thank you very much. All right. Ayan. Okay. Welcome to the third plenary session of the 41st Annual Scientific Meeting, where discussions on sustainable marine and food security will be presented. Kami po ang Team Banyera. Ay, walang nag-react. walang naka-relate. Wala bang mga mangingisda dito? Ulitin ko, kami po ang Team Banyera. Pwede. Our rapporteur for this session is Dr. Aleta Concepcion Iniguez, Outstanding Young Scientist 2017. Dr. Iniguez is currently Assistant Professor at the Marine Science Institute, University of the Philippines, Diliman, specializing in biological oceanography and ecological modeling. She obtained her Doctor of Philosophy degree from the Rosenstiel School of Marine and Atmospheric Science, University of Miami in Florida, with the support of a Fulbright and Maytag scholarships. So meron po siyang not one, but 2 scholarships. In 2018, she was one of the 8 Filipinos who were part of the Asian Scientist 100 list. Grabe. The Senate of the Philippines honored her and the other 7 scientists by adopting Senate Resolution number 141 on May 22, 2019. Beyond research, Dr. Iniguez advocates education and critical thinking through experiential learning. She has been the camp director of the DOST-SEI UPMSI Marine Science and Climate Change Summer Camp for public high school students for 11 years. Meron po siyang FB blog. Ang pamagat po ay Baybay Dagat. So, i-follow po natin yun. It's really an interesting blog. Please stand to be recognized. Dr. Iniguez, kaway-kaway tayo dyan. Ayan, palakpakan po natin siya. Okay, let me now introduce our first speaker for plenary session 3. He is a marine biologist with interests in biological oceanography, coastal ecology, fisheries biology, marine protected areas, and fisheries management. He holds a Master's of Science in Marine Biology from the same school as Dr. Iniguez from the Rosiantiel School of Marine and Atmospheric Science of the University of Miami, and a Doctor of Natural Sciences in Marine Biology from the University of Hamburg. He has authored over 65 publications in peer-reviewed journals, conducted over 50 researches in various aspects of marine biology and fisheries, and served in committees of over 50 MS and PhD graduates. Our speaker is also a core member of the recently formed National Science Advisory Group to the Bureau of Fisheries and Aquatic Resources, and is currently a professor at the Division of Biological Sciences College of Arts and Sciences of the University of the Philippines, Visayas, which he joined in 1996 and heads the UPV Ocean Biolab. It is his birthday today. So join me in singing, Happy birthday to you. Happy birthday to you. Happy birthday, happy birthday. Happy birthday to you. All right. Well, we would like to remind our speaker that he will be given 30 minutes for his presentation. When your time is up, you will hear this bell sound. Ayun. Ting. Let us all welcome Dr. Wilfredo L. Campos. Sir.
Thank you, Muji. Good afternoon. I will be talking about challenges in regaining sustainability in fisheries, in Philippine capture fisheries. On the right, I'm showing annual fisheries production in metric tons, the percent contribution of the three sectors: aquaculture, municipal, and commercial fishing. Municipal and commercial fishing are what we refer to as capture fisheries. The municipal capture fisheries sector are made up of small-scale fishers who have vessels that are not larger than 3 gross tons. And commercial fishers are those that have larger vessels. From 2000, the last 10 years, the average production was, fishing production was 4.8 million metric tons per year, with aquaculture and capture fisheries contributing about 50%. Okay, in 2018, capture fisheries production produced about 2 million metric tons. Globally, in 2016, the Philippines ranked 11 in total fisheries production in the world, contributing 2.2% of global marine capture fisheries. So these are rather impressive statistics for a country like the Philippines, for the size of the Philippines. Okay, I'm showing a surplus production model. This is what fishery scientists use. I'm sorry I don't have a laser, but the horizontal axis at the bottom is fishing effort, it increases from the left to your right. And on the vertical axis, we have annual catch in millions of metric tons. And the dots show the annual catch corresponding to respective effort for various years, starting from 1950. Okay, so this information is pertains to small pelagic fishes. These include galunggong, of course, our favorite galunggong, the sardines. They also include jacks, mga talakitok, no? And the hasa-hasa, and many other kinds of fish. No? Okay, so the current responding to fishing pressure, meaning the abundance levels are not producing as much, are not keeping up with the fishing effort. No? So that's when the curve starts tapering off, no? So that we see that in the mid-1970s, fisheries production over small pelagic fishery stocks in the country had breached the carrying capacity of our fishing grounds. Okay, that was 40 years ago, almost 50 years ago. And in the late 1980s, the data don't go farther than this. The condition was worse than the decade before. Okay, so that we see from these resources that our small pelagic resources were already fully exploited in the 1970s and overexploited in the 1980s. Okay, this work was done in 1987, published in 1987, so we've known this for over 30 years. Okay. So let's look at other resources. These are demersal resources. They include bisugo over there, danggit. No? They also include other soft-bottom demersal resources. And I'm also showing, instead of fishing effort, I'm showing fishing mortality, which is a function of fishing effort. It decreases on the horizontal axis from left to right. And catch also increases from the bottom up. And we see the same curve. No? So that in the late 70s to 80s, we see that production had tapered off. And in the late 80s, which is no longer included here, if you follow the curve, then we can almost say that the condition was overfished. So we see something very similar to our small pelagic resources, that in the 1970s, these resources were already fully exploited, and in the 1980s, overexploited over the carrying capacity of the resources. Okay, I'm showing here the Dicapterus is what we call galunggong, no? And I'm showing here a map of the Philippines showing data for 17 different stocks. We call them GG for galunggong, no? Different species, no? And different stocks in different fishing grounds. And this is based on updated information from the National Stock Assessment Program of the Bureau of Fisheries and Aquatic Resources. And out of the 17 stocks, we see only one stock that appears to be viable. That green point down there in Pojada Bay, Davao Oriental. All the rest of the stocks, the red dots, show that the galunggong stocks are OSET. That's what the data tell us. If you look at sardines, sardines are made up of several species. Together with galunggong, they make up the bulk of our marine capture fisheries in the Philippines. So the same thing, I'm looking at 15 sardine stocks all over the country. The data range from 1965 to 2014. So there are 3 of the 15 dots that show viable stocks. Okay. These 3 are not recently assessed areas, so they might already be red by now. Okay. So our most recent estimates show that sardine stocks are overexploited by about 28%. Okay. So we're fishing them at a level that's about 28% more. Okay, I'm showing here exploitation rates in terms of numbers. The target or optimum range is generally considered between 0.3 and 0.5. Exploitation rate is the amount of fish that is the proportion of total mortality from the stock that is due to fishing. So it should only be between 30 to 50% of total mortality, the yellow band. No? All the blue dots in each of the graphs show the computed exploitation rates for many different kinds of species, okay, and different fishing grounds in the Philippines. So to the right, we have a map of the Philippines showing where the different stocks have been assessed, okay, from 1960 to 2000. And these refer to, at the top, to sardines and to dilis, no, anchovies. Okay? And then the middle, we're looking at matambaka, no, big ice cads, and we're looking at hasa-hasa, no, Indian mackerel. And then at the bottom, tulingan, tuna, and galunggong. These are very common to us, and we see that most of the dots are above the line of the target range or optimum range of exploitation, showing that more than 80% of the recent estimates are above 0.5, showing that more than 80% of these stocks had already been overfished in that time frame. Okay. Let's look at the small-scale fishers. This data is from interviews done in Honda Bay, Palawan, which we consider as one of the last frontiers of the country, for various gear types from the 1980s to 2000, and the dots show the catch rates of each fisherman, fisher during those decades, and we show general decrease even in Honda Bay, so that in 2020, if we follow the curve, the catch rates are going to be low or a bit lower. Okay, another set of information from Ulango, Cebu, combined with data from Tukuran, Zamboanga, okay, from various types of gear being used for the small fishers, again showing at the bottom the years from 1940 to 2000, and the dots refer to different gear types, showing a decrease in the catch per trip, no, of fishers. No? Okay, they all show a parallel decrease with time. No? And these are all indicators that the abundance of our stocks are decreasing, primarily because of overfishing. Okay? And there are many other studies showing just a portion of them to the right, fishing grounds where catch rates or catch of fisher per trip has decreased over the years. No? There are many, many more examples of this. No? Just to give you a general picture that it's not isolated cases, it's all over. Okay, those are the numbers. Okay. Well, the reason why I'm not trying to paint a very, very bad picture. It is the true picture, but we need to convince our policymakers that it is an urgent situation. That's why I'm showing you all of this. No, I don't want to depress you. No, but there is a way forward, of course. No? So I showed you numbers in terms of exploitation, but it goes further than numbers. No, it goes all the way to the reproductive capacity of stocks, the capacity of the stock to replenish the population year after year. No? Okay? I'm showing here the size distribution of catches of two different species to the left and the right, ranging from 10 to 20 here for Decapterus, galunggong, and for big ice cod, matambaka, from 12 to 22 on the right. No? Okay, and the blue bars show you the size distribution in the catches, and the red arrows show you the length at first maturity. The length at first maturity is the size at which fish become adults, mature, at size at which half of the adults are mature. Okay? And we see that the catches are dominated by juveniles. So that if you catch so many juveniles, there won't be fish left to grow into adults. So that's one thing we want to avoid, but this is a very commonplace, this is a very common situation wherever you go. Okay? And on the bottom bar graphs, I'm showing the proportion of fish in each size class. So each bar represents a size class. On the left, it's from 11 to 17 centimeters. They're not very big, they're small fish. And to the right, it's 11 to 21 centimeters. And we want to pay attention to the extent of the red bars. The extent of the red bars show you the proportion of fish in that size class that are mature. Okay? The yellow arrows are the reported lengths at first maturity in the literature. And these are not just for Philippine stocks, but for stocks in Southeast Asia, where fishing grounds are under different intensities of fishing as well. No? And we see very clearly in both cases that the reported literature values, the yellow arrows, are actually larger than what we observe is the length at first maturity. No? For example, here on the left, it's more between 13 and 14, and for the one on the right, it's more towards 14. So there is a 1 to 3 centimeter difference between what we're seeing as the length of first maturity now and those stocks in other countries, okay, or from older information. No? Okay? And we believe that early maturing fish are a response, a natural response of the populations to respond to dwindling abundances. No? They need to maintain population size, so they respond to excessive fishing and reduction in abundance by maturing earlier. Okay? So many of them are plastic enough to be able to do that. No? Okay? But there are repercussions of this, and I'll go through some of them. Okay? Fecundity is the number of eggs that an individual fish can produce. And what I'm showing here is for the Bali sardine. This is the dominant sardine in our catches in the country. And the one on the left, I have standard length on the bottom ranging from 11 to 17. And the number of eggs produced by an individual from 10,000 to 60,000 on the vertical axis. And the blue dots show the fecundity as it changes with size of this species in Zamboanga del Norte, Zamboanga Peninsula. Okay? There's another stock, I call it Bicol, but it actually extends from Ragay Gulf, Ticao Pass, and maybe even further south into Samar Sea. No? That area there. Ticao Pass is the stock in Ticao Pass is not present in that area year-round. It moves out of that area. We still really don't know where they move. No? And, but we know that they are not caught for a few months, at least in a year. And because they move out of that area, there is a seasonal refuge for the stocks. No? So in that way, they are not as heavily fished as the stock of the Zamboanga Peninsula, which is heavily fished year-round. Okay? So the blue dots also refer to the size range of fish that we were able to get from our 1 year or more than 1 year of sampling in Zamboanga Peninsula, compared to those in the Bicol area, were larger fish. And we see that the fecundity of the smaller fish is much lower than the fecundity of the larger fish. Okay, so smaller fish have lower fecundity, and larger fish have higher fecundity. If we look at egg diameter, we have smaller eggs for those produced by smaller fish. And the difference in the actual egg diameters of these stocks is a 49% difference in size, but this translates to a more than a 200% difference in the volume. No? So larger eggs have larger volumes. They can accommodate a larger larvae, more food reserves for the larvae. This translates to higher survival and higher recruitment, eventually contributes to a higher abundance in the stock. Okay? So we see for another species of Sardinella gibosa, the blue points are for Philippine stocks, fecundity, increasing with size, at a lower rate than stocks in the Bay of Bengal, west of Thailand. So again, we have smaller fish, less fecund. And this is for another kind of fish, danggit. No? Okay? And we're seeing that For Philippine stocks from Palumpon, Dumaguete, and Bolinao, the fecundity is lower than stocks in other not intensely fished parts of the world for the same species. Okay? So early maturing fish are smaller, they produce less eggs, they produce smaller eggs, and this translates to reduced recruitment. Okay? Estimated ages of fish, what I want to go just show here is we have age here on the horizontal axis and the length on the vertical axis. And the horizontal axis only goes up to 250. That means 250 days. No? We aged the fish by looking at their ear bones. The ear bones just grow like the animal. They deposit calcium material every day in rings so that when you process the otoliths, you can count the rings, no? And estimate their age. No? So the point here is we did not see any fish older than 1 year old. Okay? What are the repercussions? Fish, in this case, contribute to only 1 year class. Okay? And that year class, their offspring basically, no? If that offspring finds itself in unfavorable conditions, then they themselves will not succeed in recruitment. No? And they will not be enough spawners for that year. So it exposes, increases the vulnerability of the stock to collapse eventually. Okay? So the same thing for Sardinera limuro, nothing older than 250 days. Okay? Same thing for the other species, nothing more than 200 days. So all of these put together, small fish, less fecundity, small eggs, and no older fish in the stocks are all consequences of overfishing. And the impressions are very serious. Okay, so to avoid that, we need to, let me just skip this. Okay? Basically, my message is that there are many things that the fisheries sector has done on a local scale. They have been ineffective in many areas, effective in some areas, but for the measures to be much, much more effective and felt at the stock level, there needs to be coordination between local government units sharing the same fishing grounds. And that's probably one of the biggest challenges of managing fisheries so that we regain the sustainability. No? Okay? The other thing is there are many measures that the fisheries sector can do, but many things, including the policy, has to be supported, and investments have to come in from sectors outside of the fisheries sector. Needless to say, there is a need to reduce the amount of fishing that we are doing, both on the small-scale fishers and the large-scale fishers. That means we need to displace fishers. So there are short-term measures and long-term measures. The long-term measures have to be clear to the government so that they can be continued over the long term. So that's my take-home message. Okay, thank you very much.
Thank you, Sir Willie. So 1980s pa, na-breach na natin yung maximum sustainable yield for many of our fish stocks. In fact, there was actually a recommendation even then to reduce our fishing effort or number of fishing boats, if you may, by around 50%, noong 1980s. This session, he's a biological chemist with research interests in the Philippine marine environment and resources. His wide field of research interests ranges from marine natural products, algal polysaccharides, seaweed and seagrass utilization, and marine environmental toxicological testing. He has been awarded the title of academician by the National Academy of Science and Technology in 2010. The Professional Regulatory Commission also awarded him as Outstanding Chemist in 2012, while DOST-Picard awarded him the Pantas Award in 2013 at the University of the Philippines, Diliman, postgraduate diploma in marine pollution chemistry at the Liverpool University, UK, and Bachelor of Science in Chemistry at the University of San Carlos. He is a retired professor of the UP Marine Science Institute, but at present a scientist. We would like to remind our speaker that he will be given 20 minutes for his presentation. When your time is up, you will hear this bell sound. All right. So you can be guided accordingly. Let us welcome Academician Marco Nemesio Montaño.
Thank you. In my talk, I will deviate from the fish, but rather concentrate on the marine plants, the seaweed. I'm just going to report basically on how the Philippines was able to maintain in the list of organic ingredients in the US. So, slide one, we're in the Philippines, basically, sea, we're only 15% land, the rest is water. So our resources, basically, most of resources is under the sea. And one of the resources is the seaweed. Okay. Basically, our seaweed industry is based on these 3 seaweeds, but there are over 1,000 species. But these are the ones that are commercialized. Kappa ficus, Yuso, producers of Kappa carinan, Cucuma, producers of Iota cariginan, and Kaulurpa, which is eaten fresh, basically. Although there are inquiries from Europe and US on how to export, they need Kaulurpa to introduce into Europe. The problem now is how to maintain the hindi puputok yung bubbles. So that's a problem. But anyway, we concentrate basically on the 2, Kappa ficus and Cucuma. Produced by Okay, these are the exports of Cariginan. Basically, in 2014, we reached up to around 250 million. That is in dollars. This is the exports of the seaweed itself. Again, 250 million. These are the areas which produces the seaweed. If you look at the highest is basically mostly Mindanao. And this is basically a poverty incidence in the country. And this is the poverty highest is in Arm region, which is also the highest producer of seaweed. So there's really a need for social scientists to study that area. Because in Indonesia, there's a recent paper, they use seaweed farming to alleviate poverty or reduce poverty. Okay, these are the export destinations by countries. Most of it, basically other countries, but majority goes to the US and Europe. China basically buys, but most of them buys from Indonesia because Indonesia offers very cheaper seaweeds. And these are the export again. This is the first quarter of 2019. Same thing for them. With this Cariginan, it's a natural, non-agricultural, non-synthetic substance allowed as ingredient in organic foods. Okay, extracted from seaweeds using water dilute alkali. And then principal classifications, you have the Kappa, Iota, and Kappa, and Lambda. Okay, these are basically the current markets for Cariginan. Water viscosity, for water gels, dairy, pet food, meat. So basically, this data was done in 2010, and still there are more. If you have eaten ice cream, brushed your teeth, then you have used Cariginan. You have encountered seaweed. The U.S. Department of Agriculture, that Cariginan will be delisted from the list of organic ingredients. So these are the objections and the response of the Philippines. Basically, NOSB claims that carrageenan is low-level, long-term inflammation precursor, then ulcerative colitis like disease, intestinal lesions, intestinal ulcerations, and promoter of colon cancer. The response basically was based on the study of Weiner. Weiner said that, you see, the experiments done by Tobacman could not be repeated. And then basically there was a flaw in the experiments, and you see, they were treating carrageenan in the inflammation test rather than carrageenan as a food ingredient. And then NOSB mentioned that degraded carrageenan is in the 2B carrageenan carcinogen list, according to WHO. But again, the main response was basically on Jacfa and Weiner, that it should not be confused with polyginan, a cancer-causing polysaccharide. Then carrageenan supposed to be contributes insulin resistance and promotion of the type 2 diabetes. But again, basing on the studies, carrageenan lowers the blood glucose level. In fact, in the study of Panasige, it lowers the glycemic index. Especially if you treat it with rice, without any starches food, it lowers the glycemic index. Okay, carrageenan claims that the seaweed farmers over-harvesting the wild seaweeds to products or materials for carrageenan production. Again, this was refuted, especially by the work of Dr. Trono, Dr. Azanza, and others, who really promoted the culture of the seaweeds in the lab. Again, NOSB said that carrageenan processing plants dump potassium hydroxide to the wastewater. Again, we said that we have environmental laws which what requires the plants to have water treatment facilities by DNR. So, at the end of 2016, the safety of carrageenan as food additive was confirmed, okay, in November 2016. But still, NOSB still recommended the removal of carrageenan from the U.S. national list of food ingredients for organic products based on availability of alternatives. This was the Elan gum, which was a microbial product. So that's a concern. So what the Philippine government did was to establish that there is no alternative to carrageenan in current food applications, okay, and to keep the carrageenan organic list. Okay, what is carrageenan? It's a multifunctional substance with superior properties. These are, again, the applications in meat products, dairy products, beer, wine, soy milk, almond milk, soft candy, and thickener. Okay, carrageenan has distinct physical, chemical, and functional properties that fully replicated by other hydrocolloids. And these are the superior in the through literature. We found that effective carrageenan as a food ingredient effectively prevents lumping, crucial in attaining good quality for ice cream, prevents collapse of food foams, ensures super quality of meat products, enhances quality of surimi without negative effects on the sensory product. Basically, this is summarized again. This is excellent sensory quality of carrageenan containing products, which is important in industry, the food industry. And these are the literature which we examined Basically, most of the literature were published in Europe and US. Konti lang yung sa Asia. So, in one sense, it's good, but again, it tells that our Filipinos are not doing much research on Carrageenan. But anyway, again, this is the summary that the Carrageenan is irreplaceable as a food additive in organic products. Okay, this was the final action of the USDA Agricultural Marketing Service. It says that IASMS found sufficient evidence in the public comments that to NOSB that Carrageenan continues to be necessary for handling agricultural products because of the unavailability of wholly natural substitutes. Carrageenan with specific uses is an array of agricultural products, and public comments report that potential substitutes do not adequately replicate the functions of Carrageenan across a broad scope of use. Therefore, Carrageenan continues to meet the OFPA criteria for inclusion in the organic list. Okay. So, this Carrageenan is still on the list up to 3 years from now, which will be another review. Okay. I would like to thank these people, basically Director Abiyati of NFIDI, Mr. Ortega, Mr. Tungono, because the ones who designed the paper. And these are the scientists. You see, except for Mr. Tudrosa, the president of SIAP, all of these are academic people, belongs to the academy. Okay, and I headed the thing. Okay, thank you very much.
Thank you very much, Sir Cope. Indeed, seaweeds is important to our daily lives. Unfortunately, similar to our fish stocks, it's also facing a lot of challenges. Okay, we'll now proceed with our next panelist. Again, reminder, you'll be given 20 minutes for your presentation, sir. Our next speaker is a Mindanaoan, born in Matungao, Lanao del Norte, and raised in Iligan City. He obtained his Bachelor of Science in Zoology, magna cum laude. Ulitin ko yun, magna cum laude. In 1988, as a full scholar of the Mindanao State University Marawi main campus. He became University Research Associate at the University of the Philippines Marine Science Institute from 1988 to 1990. The Australian Equity and Merit Scholarship Scheme, or the John Crawford Scholarship, allowed him to pursue on Master of Science and PhD straight program in aquatic zoology at the University of Tasmania at Hobart, Tasmania, Australia from 1990 to 1995. From 1998 to date, he has been Professor 6. Yun na yung, ano sir, no? Pinakamataas. At the Mindanao State University Iligan Institute of Technology. Among his most prestigious awards are the Talent Search for Young Scientists in 1996 and the Outstanding Young Scientist of the Philippines in the field of zoology in 2007, both from the National Academy of Science and Technology. The Achievement Award in the Biological Sciences for 2017 from the National Research Council of the Philippines, and the Annual Achievement Award in Research from MSU IIT from 2007 to date. We call him Doc Ipe. Not sure if there's reference to Mr. Philip Salvador, but let us all welcome Dr. Efraim Metilio, sir.
So, good afternoon everyone. Magandang hapon, maayong hapon sa tanan. We're still awake? Yes, that's good to know. So, I will share some thoughts, promising thoughts, on the sustainability of Philippine marine biodiversity and food security. So by sustainability, we mean the 17 United Nations Global Sustainability Goals. There are 17, but we should keep in mind that they're all interrelated and inseparable. But my talk, as in the previous speakers of this plenary 3, is most related to SDG 14, Life Below Water. But before anything else, I'd like to flash some basic concepts on the primary dimensions of sustainable development. These are non-negotiable primary dimensions, including safeguarding long-term ecological sustainability, satisfying basic human needs, promoting inter- and intra-generational equity. In order to attain true sustainable development, we might have to look at the economic, social, ecological triad of circles. So if we listen to the talk of academician, national scientist, Dr. Cruz, this is very similar. These three circles need to overlap, meaning they are transdisciplinary. And I would like to emphasize inclusivity as an outcome of the synergy between social and economic dimensions. So previous speakers have described Philippine coastal profile, or most of us are familiar with the coastal profile. The picture in the slide is our Philippine map surrounded with the different types of lines which signify our territorial claims. I want you to focus on the yellow dash and 2 dots line, as it encloses our exclusive economic zone. And if we are to consider our EEZ and all other claims, we can actually redefine our country as a very big body of water with 7,641 islands. Meaning we should perhaps veer our thoughts and creativity on the vastness of our seas and marine waters. So our country can be the center of marine biodiversity, but our country is also a hotspot of many issues that threaten our marine biodiversity and food security. So I have listed several. But I will only be focusing on the lower 3 because our next speaker will talk about climate change. So I'll focus on illegal, unreported, unregulated fishing, inequitability, and perhaps international poaching. So on the first issue, Dr. Campos highlighted the major issue of overfishing. For me, one of the reasons the issue arises is the fact that few understand the meaning of carrying capacity as applied to fisheries. From my ecology course, carrying capacity K means the density above which a population cannot be expected to increase. So if applied to fisheries, carrying capacity is the intersection point of mortalities and births of individuals in a fish population or any marine population for that matter. So that if fishing, which represents mortality, reaches to the point of depletion, one should not expect births. No? So also, Dr. Campos emphasized the future of the fish stock depends on the number of individuals born from the parents and recruit to the population. So, if we see this graph here, on the upper right, you have series of recruitment depending on the combination of births and dying. So that the picture on the upper right side showed that the highest recruitment is the right combination of births and dying. There must be an ideal number of deaths and births in a population to sustain the population. So if we plot the net recruitment and population density, the combination generates a dome-shaped figure with the top of the dome as the optimum level of net recruitment. So I borrowed one of the slides of Dr. Campos and somehow there must be an ideal number of new or future recruits to sustain the fishery of a stock. So if you look at the red dot, that is the most critical point because recruitment numbers below the red dot means the future number of recruits will not ensure a sustained size of the population to perpetuate or continuously replace the fishery stocks. So according to a famous Filipino fishery scientist, Dr. Armada, we need fish to produce fish. So this series of pictures are somehow very similar to the one shown by Dr. Campos. So essentially, these are catch rates. So over time, against the y-axis, annual harvest or catch per unit effort. But I want you to focus on the declining red line. No? So for example, the one on the top is the demersal fisheries. This was shown earlier. The one on the bottom, the small pelagic. So pababa siya. And then the one on the top is the coral reef fishes. Pababa pa rin since 1950s. Siguro by now, the same level pa rin yung catch rates for coral reef fish. In Manila Bay, this is a result of the work of the National Fisheries Research Development Institute. By 2015, as to demersal fish, 10% na lang yung nandun sa Manila Bay compared to 1947 na data. So sa isda ito. For invertebrates, the same picture is shown. This is for the blue swimming crab in the Visayan Sea. We have declining catch over time. For pinnate shrimps, pababa pa rin in the Visayan Sea. This one is sea urchin. And this is for the sea cucumbers. So essentially, before 1990, there was not much interest in sea cucumbers, but 1990 onwards, there was a sudden demand for export of sea cucumbers. Then we have the declining red line. But so essentially, those red lines actually is a phenomenon in fisheries, which I learned from Daniel Pauly. He called it the shifting baseline syndrome. So you have on the y-axis something good, something of a good thing like fish, and then the x-axis time. So essentially, pababa yung linya as we saw in the series of examples. And along the way, we have the option, we have three options. So either to rebuild, maintain, or continuously deplete our stocks. So, but according to Dr. Campos, there will be a point of no recovery or the tipping point. So it's really up to us if we continue to deplete our fish stocks. And one of the recommendations of the United Nations, FAO, Food and Agriculture Organization, is to take the approach of the ecosystem approach to fisheries management, where we should not only confine on the fish itself, but all the interconnections associated with the fish. So I'm a biologist, so I'm more into the biotic components, but fisheries is also driven by market forces, climate, and different institutions in the country, national government offices, and so on, no? And also the abiotic component. So this might be a very good approach to managing our fish stocks. And the ecosystems approach seems to be very promising because I had one experience. I live in Dipolog City, but I work in Iligan City, where I requested the vendor to open the stomach of juvenile yellowfin tuna, and to my surprise, I saw 4 individuals of sardines. And this was after the closure, the 3-month closure in the Zamboanga Peninsula. So it was really very inspiring na somehow, if we manage our small pelagic fish like sardines, we are also managing the large, more high-value species of fish. So, Dipolog is within Sulusi, close to Sulusi. And this is, if you see the enclosure there, that's the Bohol Sea on the right side and the Sulusi on the left side. So these seas are very important for me because there are so many things that are happening there that are worth conserving or protecting. So for example, Dr. Villanoy's, academician Villanoy discovered the Bohol jet during the northeast monsoon. This is a very strong current south of Bohol Sea. And close to Iligan Bay, we have the Iligan Eddy, also reported by academician Villanoy. And previous scientists, other scientists like Dr. Gil Jacinto, Dr. McGlone, reported wave series from Palawan down to the Sulu archipelago. We call it the SAGE. And if the SAGE can be very strong, it can damage coastal communities. Also reported by Dr. Villanoy's group is the Northeast Monsoon Coastal Upwelling event, where you have biological enrichment during Amihan, so in Butuan Bay, close to Camiguin, and also the northern Zamboanga Peninsula. Also, this enrichment were reported by our Chinese colleagues. Na year-round, very high primary production in the Sulu archipelago and also close to Sabah. And if you go to the Dipolog City Market, you can still see all these large pelagic species like sharks and the swordfish, the black marlin, and the sailfin marlin. You know? About 4 to 5 species of tuna, dolphin fish can also be bought in the market. And of course, our tulingan, the oxys or the bonitos, the galungongs, and manta rays and whale sharks also are very common in Bohol Sea and Sulu Seas. And then perhaps because of the sardines, and also perhaps because of high abundance of zooplankton like copepods and krill, and of course your primary producers, the phytoplankton. So I thought maybe these ecosystems are worth, or this ecosystem is worth preserving to sustain our food security. I've not included the marine mammals, no, but marine mammals are also very important, very common also in Bohol and Sulu Seas. So, MSUIT has created a Department of Marine Science, and probably we can make the Bohol and Sulu Seas as a main research and development initiative in the next 50 to 100 years. So, we will be proposing making some projects. We call it CREST. And then, of course, anchored on the ecological, socio-economic triad, where you have the importance of science and education, policy and governance, and empowerment to our local people. So the national government has actually implemented joint administrative orders to close fishing 3 months, more or less For example, in 2011, the Zamboanga Peninsula, we have fishing closure November, December, January. And in Visayan Sea, 2013, 2015. So more or less this effort, which I think are precautionary approaches, would help marine ecosystems in these areas. Okay, we did close at the Zamboanga Peninsula, help or knock on the door of the government to have something to close the closure in the Zamboanga Peninsula, and then the following year there was a sudden increase of sardine catch. But over the years, since the closure, the sardine stocks are quite variable. In fact, in 2016, the catch was quite low. So somehow with sardines being a plankton feeder is also connected to the variability of climate and availability of their food, no? Because sardines, as we have studied, they are mainly zooplanktivores. So closure is not enough, definitely, and some marine scientists have done modeling that there has to be a combination of marine protected areas and harvest control. So in fact, harvest control alone can ensure sustainability of certain pelagic stocks. So it's good to combine marine protected areas and harvest control. Okay. So I'd like to also emphasize now we might develop our security and sustainability sa marine ecosystem, marine environment, but we should not forget inclusivity or helping our poor people elevate their economic status. For example, as presented by Dr. Academician Montaño, ARM and Zamboanga Region 9 produces so much seaweeds and earn a lot of revenue, but the highest poverty incidents are also in this region. So bakit? And probably, as suggested by Academician Montaño, the social sciences can actually work on this. No? But maybe we should not focus on this, on the seaweed industry, because according to Academician Asansa, they have published a paper on the blue economy. We actually have more than 15 trillion peso worth of marine resources, you know, by valuation. So that's how many times our national budget, which is 3 trillion. So if we invest on our marine environment, we can sustain our national economy. We can make Philippines rich again. And as to helping efforts to helping elevating, providing higher poverty benefits, according to the United Nations Convention on Biological Diversity, nature tourism and fish spillover seem to be very feasible to help our poor countrymen and women. Okay, so I'll not deal so much on poaching. We know that the red dots are, this is reported by Oceana, the red dots are lights from fishers, and they are now encroaching into our exclusive economic zone. So maybe the national government can do something. Okay, so I would like to just make final words na probably we should change something on our heart and mind if we want to go into sustainable development, because it's in our mind that will make things happen. You know? So according to Albert Einstein, if you dream on something, that is something illogical, but you still have to dream. You know? And then I'd like to share some words na, so if you also ponder at some point in time in one day, think about the future generation. It's always a constant dialogue between now and the future in our minds. Now, how do we ensure good life, quality life to our children's children? So according to Proverbs 4, not yet. Talagang pinapaalis na ako. So anyway, according to that Proverbs, I did not memorize. We just have to guard our thoughts and minds. Okay. Be careful what you think, because your thoughts run your life. Thank you.
Thank you, Sir Ipe. Sabi nga ni Gladiator, what we do in life echoes in eternity. A lot of challenges, a lot of red, a lot of declines, a lot of many stuff, but indeed a lot of promising thoughts. Isang nabanggit ni Sir Ipe yung ecosystem approach to fisheries management, which I think is a really good way to address many of these issues. Okay, allow me to introduce our last panelist speaker for today. He has been elected to the National Academy of Science and Technology Philippines, the highest recognition body on science and technology in the country, for his significant research contributions in the field of physical oceanography that contributed to the understanding of ocean circulation and variability of seas around and within the Philippines. His researches are very relevant to the pressing concerns of the country, particularly in fisheries, harmful algal blooms, storm surges, and other complex dynamics of archipelagic oceanography. He has authored over 80 published papers in Scopus and non-Scopus journals. He was named as one of the outstanding young scientists in 1997 by DOST-Philippines. He finished his BS Zoology degree at the University of the Philippines, Los Baños in 1981. He obtained his MS and PhD Physical Oceanography from the University of Sydney in 1988 and 1993 respectively. Ito po, alam ko, ang tawag po natin sa kanya ay, or is popularly known as K or Sir K. Hindi po siya agent ng Men in Black, but K for kulot. Now you know. Ladies and gentlemen, let's all welcome Academician Cesar Villanoy.
Magandang hapon po sa inyo lahat. I'll start with this figure which shows the fisheries production from 2002 to 2018. So the dark blue line represents seaweed production. So yan yung pinakamataas nating production sa marine. And then the light blue line represents the commercial capture fisheries catch. So 2018, slightly less than 1 million tons a year. Almost the same amount yung municipal catch. Municipal catch is fish caught within 15 kilometers from the coast. So halos 50-50 yung marine capture fisheries and sa commercial at saka sa municipal. And the green line is aquaculture. So what is striking here is that since 2010, seaweed production, marine commercial, marine municipal fisheries has been going down. Aquaculture na lang yung umaakyat. And if you look at our population growth rate, we're growing at 1.7% per year. By 2018, there will be, 2018 lumampas na pala. So, ang estimate based on the 2015 census, that's about 106 million population in 2018. Sabi ng BIFAR, average Filipino will consume 38 kilograms of fish a year. So that's total fish requirement of 4 million tons. We are only producing 2.8. Deficit natin is more than 1 million tons, and this is an amount that cannot even be supplied by commercial fishing. No? What is even more worrying is that the population is increasing by 1.7%, but our fish production is decreasing by 0.6% per year. No? So we have a 50% shortfall in fish production. Though that's like 40 million Filipinos will need to stop eating fish and start eating chicken instead. So my presentation will be to summarize the talks that were given during the regional science meetings in Luzon, Visayas, and Mindanao, and relate that with the presentation that was given by our speaker today. So during the Visayas RSM, the first talk was given by Dr. Geronimo, who looked at climate change effects on our fisheries. And he did this by getting climate data from climate models, which for the Philippines shows increasing temperatures by about half a degree in the next 30 years. So from 2050 would be warmer by about half a degree for most of the country, particularly in the south. And he looked at different species, looked at their preferred temperature ranges or preferred habitat conditions, and related that with the increasing, changing environment, and got estimates of how much the preferred habitats of specific organism or specific fish species would increase or decrease by 2050. So the figures on the right shows the projected suitable habitat of yung dilis, a species of anchovy, Stolophoros. The red represents, yung blue dyan represents the preferred habitats. So sa 2000, yung blue niyan, yun yung preferred habitat ng dilis. 2050, nawala na yung blue. So we have a reduction of habitats and came up with a list of different species and by how much their habitats would decrease or increase by 2050. So yung nasa pinakataas, yung bulinaw or parang dilis din siya, by 2050, 30% na lang yung extent ng kanyang habitat. So malaki yung impact, pero ang recommendations niya is that these estimates were made using very simple models, and we need to understand better the interaction or the dynamics between the fish and its environment. We also need to act now. We don't have to wait for the climate to change before we do something about it. And invest in improving our science, reduce the uncertainties. Filipinos also are not very good in monitoring. We do not have very long-term data sets, and we need to expand in invest in monitoring programs. So the other speaker was Dr. Mamawag from CIFDEC, and he was looking at aquaculture. Aquaculture is seen to supply the shortfall in capture fisheries. And this figure here on the left is the global fish meal production, and a majority of the global fish meal production is used in aquaculture. So we are actually feeding fish with fish, no? So it's hardly sustainable. No? So what they're looking at is exploring alternatives for fish meal. So they've done a lot of studies using plant products, copra, kahit water hyacinth as substitute for fish meal. And their goal is to reduce the use of fish meal and fish oil and explore the most efficient conversion of nutrients. But it has also to be environmentally sensible and sustainable. During the Luzon RSM meeting, we had two presentations about aquaculture. One is by Dr. Menyes, who looked at two of the most important commercially important invertebrates, the sea urchin and the sea cucumber. These are high value and has a very high demand. That's why most of our national stocks have been depleted. And so she developed hatchery culture technology and developed this culture-based resource management where they use hatchery culture to fast-track the increase in population. So making recovery of natural stocks faster than just leaving them alone. And they've done some examples of this in Bolinao, and they are scaling up some of their experiments nationwide. So the major challenges in this approach is how to scale up so that you gain long-term ecological and equitable socioeconomic benefits, and as always, establishing and sustaining good governance systems. The other presentation was by Dr. McLone, who looked at the environmental impacts of mariculture. The sustainable mariculture translates to environmental sustainability. Mariculture is has a very large impact on the environment because of the feeds, the waste. It has caused serious environmental problems in our major mariculture areas in Bolinao, Pangasinan, in Dagupan, even in Taal and Laguna Lakes. So she showed some learnings from the Bolinao experience and how investigations on how to estimate carrying capacity for mariculture should be done. She also recommended exploring feed quality and feed practices to reduce the waste, and also to monitor water quality, which should be a basis for estimating carrying capacity. Again, nandun pa rin na naman ang strong political will to implement the rules. So sa Coronadal, during the Mindanao RSM, si Academician Santos nag-present ng WTF, where's the fish? He also did not miss the opportunity to explain what his name means. Na mahangin daw siya. But he talked about the large oceanic pelagic species, lalo na yung mga tuna stocks. So he showed some assessments made by the West and Central Pacific Fisheries Commission, where every year they send out stock status and advice on the state of the stocks for the different species. So yung mga, for example, yung mga naka-highlight in pink are the species that are already overfished. They've also showed some examples of The recommendations made by Academician Santos was to implement marami ng management plans na nagawa for the different, for tuna, for sharks and rays. Kailangan talaga ng good governance and political will. Na-establish na rin yung mga FMAs or fisheries management areas. So we need to support that and apply ecosystem approach to fisheries management. Academician Montaño also presented a talk about the Philippine seaweed industry, and he gave a presentation also today, highlighting the importance of the seaweed industry and what we need to do to sustain or make the seaweed industry sustainable. As we've shown in the first slide, kahit nga ngayon, our seaweed production is already decreasing. And so we need to act now. This is a slide from our speaker, and na-disturb talaga ako doon sa figure sa upper right, which is the catch rates na municipal fisheries. Since the 1980s, fisher can catch more than 40 kilos in a day. Nasa edge nung graph, which is next year, parang nasa zero na. So, ina-highlight lang talaga niya na our fisheries stocks are really overfished. Nasa critical state na. And we need to make very difficult sacrifices. We need to let the overfished stocks to recover, and to do that, we need to reduce fishing pressure. We need to catch less fish so that more fish will be able to reproduce. Well, the other alternative is we start eating more chicken. Thank you very much.
Okay, Sir Kay, thank you very much. Matutuwa sa iyo ang Jollibee at ang McDo. Okay, at this juncture, we will proceed with the open forum to entertain questions from the audience. Priority will be given to written questions. We do have a lot of time for Q&A, so please submit your questions here. For the first one, this came from Sir Renerio Kentalan Jr. from the Institute of Crop Science, UPLB. With the concept of decreasing fish stocks and the concept of tipping point in mind, could this also indicate the narrowing of the genetic base of the fish population? If yes, what are the current efforts to assess interspecific diversity and its effects to population vulnerability and resilience? So may epekto daw ba sa genetics? And are there any efforts being done towards that? Nagpapalit na ba yung kanilang...
Eventually, that could contribute to the narrowing of the gene base if you have less and less fish that are left. No? Although the fishing grounds are all connected to one another, and that opens up mixing of populations as well. This needs to be looked into, actually. And I cannot really answer if that is a significant factor or that will be a significant result of long-term overfishing.
Yeah, if I may add, actually, we have a collaborative project with Dr. Kent Carpenter and Jeff Williams. We got an NSF project where we're going to compare the genome of the fish caught this year and same species caught in 1908 during the albatross expedition. And we're going to compare their genomes and see what happened. Whether actually addressing this question, there were significant changes in their genome patterns and also like computing for effective population size before and now, something like that. So I think this is one example of an effort that we're currently doing to address this question. Okay. Other questions? Parang nalungkot ba kayo masyado dun sa puro pula na nakita niyong status ng ating stocks? Wala bang magtatanong sa mga younger generations? Ito pa, okay. Okay, this is from Francis de los Reyes from North Carolina State University. Oh, phone-in question ba to? Or, are there models showing the effects of ecosystem management? We've seen the problems, but are the proposed solutions adequate? Or do we need fishing quotas / limits? Are there studies showing that ecosystem management is effective or not? Or do we just need to limit fishing pressure or put in fishing quotas?
I think sa ngayon, we do not have fishing quotas. We do not have models which could show what fishing quotas would help, how it would help. Meron lang tayong closures, fishing closures in selected areas. These are based on some monitoring data ng reproductive stages ng fishes. But we have some ecosystem models, but they need to be validated.
Okay. Ma'am Rod, you were saying something?
I'd like to add that I'm not sure if we have studies looking at effects, ecosystem level effects, but by qualitative or descriptive observations, we can clearly show disappearances of species. And that's very drastic because, of course, if species will have reduced numbers of population, then it will have huge effects on the ecosystem.
I think I have to remind you of the work of Dr. Elino and Dr. Alcala on marine protected areas. So how are these marine protected areas affecting positively your fish, being capture fisheries? This has been, this has been reported before, but you can relate this report to your topic, I think.
Thank you, ma'am. I think I read recently a paper which showed that if you combine fishing closures with MPAs, you would actually increase the population of your large fishes. So I think that's one effect, ma'am. Pero sabi nila in combination is more effective than independently being done. Okay, other questions? Paliit na ang mga sulat. I would rather not be named. Thank you. Okay, as early as 1900s, there had been already a decline in our captured fisheries. I think we are already aware of the challenges in our Philippine fisheries, such as overfishing, illegal fishing, juvenile catching, and so on. My question is, aside from closed fishing policies, aquaculture, and alternative livelihood, what are our other strategies in addressing this problem? And ultimately, be fish food secured. We are aware of EAFM. In fact, it has already been incorporated in our Fisheries Code, Republic Act 10654. Care to comment on that? She's asking about other strategies that you think can solve these problems, aside from EAFM and closed fishing and aquaculture and alternative livelihood. Other ideas daw po.
I can only think of one thing, population control.
All right. Or eat chicken.
There are issues that need to be addressed outside of the fishing sector. I think that's systemic for many things. But there have been several fronts in which measures have been introduced at the local level. And these need to be upscaled, including marine protected areas and networks of marine protected areas. In other words, there needs to be support in terms of all-around support, infrastructure and government support from all the different departments for these short-term, smaller or finer scale measures to be able to be upscaled to the fishing ground and to now the fishing management areas. But the broad policies need to be clear. Population control, the issue of equitability, the issue of not just alternative but really long-term opportunities for the sector that is currently in fishing as well.
All right. Another question, is there a way to lessen the change of reproductive biology of commercially important fish species? Way to lessen the change of reproductive biology. Lessen daw the change, sir, of maybe...
In the reproductive biology, the overfishing has been going on for 2-3 decades, so that's very long. But in northern countries, in higher latitudes, they've seen indicators of reproductive capacity change within the short term in response to certain measures. So we have not tried that. We have not been able to monitor that yet in the Philippines. So there are opportunities of doing that on a fishing ground basis, and perhaps we should be looking at that also. If to really see if those reproductive, how the time frame in which our stocks can recover and regain sustainability. Right now, it's very difficult to say.
Okay. Another question from Ms. Erlinda Mari from DOST-FPRDI. What is the basis of our per capita consumption? 100 grams per day historical, or FNRI's recommendation for daily fish consumption? Ano daw yun po yung basis ng per capita consumption? Is it FNRI?
I got that figure from BIFAR's website.
I'm not from BIFAR, so I cannot touch it. Okay, so I guess we just have to look for that one. May pahabol. Again, ito, no name, smiley. Is implementation of closed season on certain species like galunggong really effective? What are your view, comment on galunggong importation? Hot issue ang galunggong.
In terms of the closed season first, it will work if there's compliance. No? Enforcement can only work if there's also voluntary compliance by all the stakeholders. No? Compliance is still a concern, and that needs to be worked on. I know, for example, in the sardine close season, if there is improving compliance in the Visayan Sea, right after the close season, the sardines have spawned, the early juveniles are there. It opened up fisheries that targeted the early juveniles. No? So that is another measure that needs to be taken now. No? So Philippine fishers are very adaptive. No? They're very resourceful. No? So we need to be on our toes all the time. No? Importation, for food security is always going to be important. No? But I just wish to, I think we all realize that your resource base to keep food security there has to be viable. So that if our resource base is just defined on galunggong, then we cannot supply what the market needs, no? Unless we import. Perhaps we need behavioral changes also. We need people who are used to eating galunggong to eat maybe tilapia or other things. There are other opportunities. No? So importation, just like rice, is needed if there is not going to be any alternative to it. There are alternatives.
Okay. And kailangan, sir, yung galunggong na in-import, hindi galing sa atin. No? Importante yun. No? Other things? Other questions? Sir, yeah, you want to add?
I think we need to, there has to be science as to evaluating or monitoring the effects of closures. I think the NFRDI has NSAP. Do you think NSAP can see effects of closures? G?
Huh?
or the National Stock Assessment Program. But as to the earlier question on what can be done to secure our national food security, so perhaps I'm a teacher, so the cheapest way to is to continuously teach our young people about keeping our ecosystems healthy. You know? So education, which will be the topic tomorrow, will be very helpful. Because I think the reason why we are not so concerned with our marine resources is because of ignorance, not so much understanding of the diverse nature of our marine resources.
Okay, sir. Noted. Monitoring ng stocks after the close season. Okay. In the interest of time, we'll just read some more questions. Please don't read my name. Okay. UP Tacloban. Looks like aquaculture could be an answer. Why not? We haven't maximized or haven't done multi-species shells, seaweed, and fish in one area, for example. Care to comment on that? Multi-species. Looks like she's saying that aquaculture can also be an important.
The answer there is responsible aquaculture.
Responsible aquaculture. Okay, just to make sure that's responsible aquaculture. Okay, and last question, Joy M. Tamayo, Central Mindanao University. Were fisher folks ever asked how they define sustainable marine management? If yes, how do they define it? Mga fisher folks daw, mga social scientists dito. Mukhang magandang topic ito for PhD thesis, no?
I have never posed a question in that way, but there has always been consultation, not by me, but there are many other efforts from from CSOs and NGOs. There's always consultation with the stakeholders, and I would think that they have a voice in that. Even in the process of formulating interventions of management by central government, the measures are a result of consultations and not prescribed by a single party. So these need to be acceptable for them to be enforceable. As I mentioned earlier, I think it's impossible to enforce many regulations looking at the topography of the country. So enforcement and compliance, acceptability to the stakeholders, voluntary compliance is very important. And that comes with acceptability, understanding what the situation is. No? So it's not, I cannot say yes, no? But I think more and more people, more and more of the stakeholders, the fishers, are understanding what we mean by sustainable. Thank you.
Okay, a round of applause again for our speakers and panelists. May I now call on NAST President, Academician Rodora Villasanza, and NAS Vice President, Academician Fabian M. Dairit, to present our certificates and tokens of appreciation. Ayan. Walang music. Okay. Si Sir Ipe pala. Mr. Philip Salvador. Ayan. And sigurado ka, sir, hindi ka kasama sa bagong release ng Men in Black International. Si Sir Kay. And to Ma'am Aleta Iniguez. Bye-bye dagat, huwag niyong kalimutan. Alright, a round of applause again for our speakers. Maraming salamat po. Ako daw po.